Okay, this is 2022 AMC 10B number 16. So we have a geometry problem right here. So we are given the rectangle with the size 4 and 8. So this is 4 and this guy is 8. And we have a square with side length 5. So I will go with this is 5 and this is 5. Since this is given as 90-degree, and then we know this is a rectangle, so that means this is also 90. So that these guys will be parallel. So I can say this is also 4. So since we have 4, 5, and we can see this is going to be just 3, we can either use Pythagorean triple, which is what I did, or Pythagorean theorem itself, okay? So whatever. So then what I'm going to do actually, I'm going to find this region, shader region, by finding the area of this rectangle and subtracting those small triangles. Maybe I should have done this way so you can kind of see a bit better. So I'm going to find the area of this rectangle and subtract those 3 small triangles, like this one, and this one. And I'll get the shaded region. This is the way that I'm going to try, but some people may want to try this one, which is I'm going to leave you guys as a challenge. Connect these two guys and find those 2 triangles and add them together, which is going to be another way to approach this problem. So that's your job, okay? So if I want to find the area of the other triangles, I need to find, this piece and maybe these 2 legs, which is I don't know yet. So, but I do know as soon as I see some right angles, especially in a triangle and parallel lines, I should hunt for similar triangles, right? Which is usually be there. So, but since we don't really have much information about the legs for the other 2 triangles, right? Then I can maybe angle chase to see if they are similar. So if I call this is alpha, and I'm going to call this is beta. So alpha and beta actually add up to 90 degrees because this is 90, so the other 2 add up to 90 as well. So that's why that's 90. And I do know this was a square, so these guys will be 90, and this is also 90. So this is straight line, this is 90. The alpha plus the 3rd angle right here should be 90 as well, which means this guy is beta. And this is 90, that means this is alpha, and this is 90, this is alpha. That is gonna tell you this is beta. And since this is 90 and this is gonna be alpha, so it's kind of hard to imagine to see there. So let's actually make it a bit bigger. Okay, so it's sometimes good to draw a bit bigger because it's not really easier to see what's going on. So I'm gonna call this is TA, maybe K. So TA, K. I'm gonna call this is B, C, and D. Okay, so this is beta and this is alpha, right? So now we know all those 3 triangles have the same angles, which will require they will be similar, right? And if they are similar, then the ratio for each corresponding side should be same, right? And before we do, this guy right here, a 3, 4, 5 triangle, the hypotenuse is 5. And we have a right triangle right here, the hypotenuse is 5. So if you look at their hypotenuse, the ratio of the hypotenuse is 5 to 5, which is 1, which means they are not just similar, they are congruent. That is why we can actually go ahead and say the angle, like alpha is opposite to 4, then the angle opposite alpha is going to be on the other triangle, is going to be right here, which is going to be 4. Because they are not just similar, they are congruent. So which is why the other leg will be 3. And I do know AB was 4 because that was 4. And KB is 3, that means AK is 1. So that's just 1. That's something. Only thing that we are missing right now is this leg. But I do know that all 3 triangles were similar. The ratio was 3 to 4 for the legs. But the alpha was the opposite to 4, right? So which means if I compare the legs, that is 3 to 4 ratio, which is alpha is going to be opposite to larger leg, which is 1 in this case. So I can write this guy as 4 over 4, right? And if this is the opposite leg, that means this guy will be 3 over 4 because this is 4 over 4, this is 3 over 4. So that means 3 to 4 ratio. And if you really want to find the hypotenuse, that will be 4/5. So I just use the 3/4/5 again. 3/4/5 just multiply by 1/4 to get the size for that triangle. Anyway, you don't really need this guy, but I just did it anyway. So the whole region now, the shaded region basically. So shaded region is equal to area of this blue rectangle, which is gonna be 4 times 7 minus area of this guy, which is 4 times 3/2, right? But I do have the same thing right here, so I don't want to do the same thing. I'm going to multiply this by 2. And area of the smaller one, which is actually right here, is subtract 3/4 times 1/2. So if you just do the subtraction, so that will give me 15 and 5/8, okay? Which is our answer choice D. So we just use the Pythagorean triples and the similar triangle. So similarity is always big deal. And then this is the, I guess, third, maybe fourth problem just this year that I use the similarity to solve some geometry problems, okay? So similarity is always gonna be a challenge. So if you feel you are not ready for it, so I will suggest you to work on the similar triangles as always, okay? So that is it.